Hey, I'm Elena from Ladies Storm Hackathons, and I'm here to teach you a bit about Git. Git is one of the most notoriously confusing topics for beginning coders, and in my experience, it isn't taught very well in school. My goal in the next 30 minutes or so is to teach you the basics of using Git. I hope to motivate this tutorial by providing examples that give you an idea of why Git might be useful. Let's get started, and that pun was totally intended. So what is Git? A lot of times in tech, more experienced people toss around these buzzwords and expect everyone to know what they're talking about. That is a personal pet peeve of mine. So I'd rather assume that you have no prior knowledge about Git, and we'll start from the beginning. So to explain Git, I'm going to pull out one of my favorite analogies. No, Git is not a game, but what Git does can be explained quite well by video games. Here's an example. When you're playing a video game, you may want to save your progress at some point. Maybe you just defeated a key boss. It is imperative that you save your progress at many points throughout gameplay, because if you mess things up later, you know that you can go back to a good point in the game and try again. Git is similar. Git allows you, the coder, to save your progress on a codebase at any given time. Git exists so that you can modify, break, and fix your code without fearing that you will mess it up permanently. If you break your code, but have a save point where your code worked at some time in the past, you can always go back to that save point and try again. So time for the less fun, more techie explanation. Video game example is super fun, but you need a bit more than that to really understand Git. Git is a version control system. It allows you, the coder, to create a history for your code using save points. In other words, Git holds a history of multiple versions of your code from the start to the bitter end. Git leaves it up to you as the coder to decide when to create these save points in your history. Git allows you to create them whenever you see fit, honestly. Some common situations where it is a good idea to create save points include adding a function, creating a feature, or fixing a bug. Git allows many people to edit the same code without overwriting each other. You and your friends can work on different features and ideas within the same codebase at the same time using Git. For this reason, Git is a great tool for collaboration, but I'll cover more on that later. The takeaway? All in all, Git is created in order to make utterly trashing a codebase very, very difficult. Thus, using Git is to your advantage as a programmer once you get a bit more familiar with it. So, Git while alone, and FYI, a lot of these images are going to be from Neko Atsume, a wonderful, wonderful, at least iPhone app. Maybe it's on Android too. Cool, so before we start talking about using Git as an individual, I want to clear up some buzzwords you might have heard others using in discussing Git. I defined Git previously, but often beginning coders conflate Git and GitHub. Git is a version control system that keeps track of the history of a codebase. GitHub, on the other hand, is a popular website for hosting Git repositories. Most terminology and commands that I discuss will be from Git. If there are any GitHub-specific terms, I'll be sure to say so. A repository, or otherwise called repo, is where the history of a given codebase is stored. One repository typically holds one project, which may comprise of many files and folders. I'll discuss repos in more detail when I get to local versus remote. The staging area keeps track of the statuses of different files in the codebase. Have they been edited recently? Is the coder ready to incorporate them into the code history? The staging area answers all these questions and many more. I'll cover the staging area in a lot more detail in a few slides. A commit is a saved version of code at a given point in time. Commits are organized by commit messages, which the programmer writes to keep track of the changes they made to the most recent version of the code. Local versus remote is a key concept in Git. I cannot emphasize this enough. I know I said I would not discuss the collaborative usage of Git right away, but I really think that the importance of this concept supersedes that. Local repos encapsulate the history of the codebase that you have created. Only you can see the code versions in your local repo. In contrast, the remote repo is visible to any fellow contributors that you may have on a given codebase. In this case, the remote repo holds the combined history of each contributor's local repos. Oops, sorry about that. If there are no other contributors besides you, the remote repo can be private to you or visible to any one of your choosing. In this case, the remote repo will mirror the local repo, so long as you keep updating the remote repo with all the changes you make in your local repo. I'll follow up with the definitions of these terms when they appear in my slides to keep them fresh in your mind. For now, we're going to focus on using Git as an individual, which primarily means working in the local repo. There are 6 relevant commands for beginners. These commands are usable on the command line, and I'll show a few demos of that soon. First of all, we have git init. This is used to initialize a Git repo. What does that really mean? Essentially, git init turns a directory, or file path or folder, whatever term you like, on your computer into a Git repo, which gives you the power to create a version control-based history for all the contents of that directory. After initializing a Git repo in a directory, you will start to keep track of local changes within that directory. These can be easily visualized using our next command, git status. As I just noted, git status allows the coder to visualize the staging area. As I mentioned previously, the staging area keeps track of the statuses of all files in the directory that was initialized to be a Git repo. Statuses include staged for commit, which means that this file was marked by the coder to be put in the next save point, or version of the codebase. Unstaged but modified, which means that this file was recently edited, and thus Git suggests that it should be staged for commit in the near future. Untracked, which means that this file was not seen in previous versions of the code, which probably means that it was either a file that was recently created or maybe recently deleted. Git status should be used often by beginning coders in order to gain a visual for what's really going on in their Git repo. Git add. So how do we mark files with the staged for commit status? The answer is looking right at you. Git add stages files that previously had statuses of untracked or unstaged but modified. Every file that has been moved to the staged for commit part of the staging area is set up to be added to the code's history as a commit. There are 2 major ways that beginning developers should be using git add. First, using git add on individual files. To do this, you simply type git add and then the file name into the command line. I give an example of the slide of adding a file called main.py. Secondly, another instance in which git add can be used is on all untracked and modified files. To do this, you type git add -A into the command line. The -A component of this command is known as a flag. Now that we've used git add to mark files as staged for commit, we can finally use git commit in order to actually commit them to the code's history. Reminder, a commit is a saved version of the code at a given point in time. This is the video game save point from our earlier analogy. True to its name, git commit saves a snapshot of the code that holds all the staged files along with the most recently committed version of all files that were not staged. As mentioned earlier, commits are organized by commit messages, in which the coder writes what changes they made in their current commit. For instance, if I added a speaking page to my personal website, which I recently did, I probably had a commit with a message somewhere that said, add speaking page, or something like that. Commits are for you, the coder, or anyone else looking at your code to stay organized and keep track of your thinking and then your progress. In typing git commit into the command line, the -m flag and then a commit message in quotes are added on in order to facilitate you creating a commit with a corresponding message. Git log gives the coder a bird's eye view of their entire commit history. This history is listed commit by commit, with each commit message, timestamp, and alphanumeric identifier featured quite prominently. Git log is useful for visualizing your code's history and, if need be, going back in your code's history to the latest version or save point where things were working as you desired. Git diff allows the coder to see what changes they made to files in their local repo since their last commit. Git commit is similar to git status, except it shows differences between the last commit and the current version of the code line by line. So now we've made it to our first demo about local repos. I'm going to switch on over to my command line interface. Cool. So first things first, I want to see where I am exactly. I'm on my desktop. This is wonderful. So I'm going to create a folder. Actually, let me see if I already made this folder. Yeah, I called it alone because you're using Git while alone. So now we're in the folder alone. Cool. Let's focus on the actual Git stuff. First things first, I'm going to initialize a Git repository in alone. So now alone, the directory, has become a Git repository. I'm going to check Git status, and I haven't done anything in this directory. It's empty, so there's nothing here. I'm going to create a file called main.py. Now note, touch is not a Git command, it's just a command line command. And now, if I type git status, this file main.py is untracked, because it does not show up in my commit history, and that's because I don't have a commit history yet. So let's put it into my commit history. I'm going to call git add main.py. Then I can type git status in, and as you see, I misspelled it. I'll type git status in, and as you can see, main.py is staged to be committed. So now I'm going to actually commit it with the commit message adds main.py to be super explicit. And now that this commit has hopefully gone through, we should see it within git log. And here you have it. Here is the nice little identifier of the commit. Here's my name, I'm the author. And here's the commit message. Here's the timestamp. Cool. So now we're going to do a little bit more stuff here with a new file. So I'm going to create function.py. So now we can check git status, and as you might guess, function.py is going to be untracked. And you might ask why main.py is not showing up in the staging area. That's because it doesn't fall into any of the three statuses we discussed. Like, it hasn't been modified, it is the same as it was since the last commit, so there's nothing new with it. It does not need to show up in this staging area. Cool. So now I'm going to make a little bit edits to main.py to change that. I'm just going to say print hello world. Cool. So as you just saw, I updated the contents of main.py, so now it's going to show up in the unstaged area of the staging area, and then there's going to be function.py in the with an untracked status. Cool. So now if I type git diff, which we talked about, you can see the line-by-line changes between main.py as it stood before and as it stands now. There's a little plus sign by print hello world, and that is green, which suggests that that was added. So the difference between our last commit and what the code currently is that the line print hello world was added to main.py. Cool. So now I'm going to add all of the files, so main.py and function.py. Git status should reflect this change. And then now I want to make a commit message to show this. So I'm going to say updates main.py and adds function.py. Let's see if git log shows this. Cool, so you got a new commit with a new identifier, new timestamp, etc. So now in this Git repo, the history shows that there are two commits, one in which main.py is added, and another save point in which main.py is updated, and function.py is added. Cool. So that was our first demo. Now we're gonna go back to the slides and talk a little bit more about local and remote repositories. Clearly, local repos have a lot of awesome features. Most notably, they allow you to create a saved history of your code organized by commits. Then why did we talk about remote repos several slides ago? What advantages does working with remote repos offer? As an individual or team coder, you may find remote repos useful because they allow you to back up your code outside of your computer. This is where GitHub comes in handy. A GitHub repo can serve as the remote repo for your local repo that's just resting on your computer. Remote repos support team collaboration, but we'll discuss this more in a few minutes. One common reason why beginning coders will find remote repos super useful is that they allow you to showcase your hard work to others. Have you ever been asked by an employer for your GitHub account? If not, it's totally okay. You may be soon. Employers like to look at your remote repos on GitHub in order to see what you've been creating. Learning about remote repos is a necessary prerequisite before you can get to the step where you're showing off your code to maybe a future employer. Finally, one of my personal favorite motivators for using remote repos is contributing to open source. But that's not the point of today's talk. But if you're interested in learning more about open source, I would recommend that you check out a Medium post that I wrote called 99 Problems, and I will share that link when I put up these slides and this video in the Ladies Storm Hackathons GitHub repository. Okay, before we do a brief tutorial on the flow of working with both local and remote repos as an individual coder, I would like to teach you one more Git command. Git push updates a remote repository, that is, whichever remote repo you link to your local repo, with the latest commits from that local repo. A common command is git push origin master, where, in somewhat oversimplified terms, origin is the remote repo and master is the local repo. I'll explain this in a bit more detail when we discuss branching. The big question of the moment is, how do we connect local and remote repos? Well, I'll show you how in our next tutorial. And by tutorial, I mean demo. Cool. So I'm going to actually switch gears and exit out of this slideshow in order to go over to GitHub. Okay, so this is my GitHub. I'm going to create a new repository. Or wait, actually I might have one waiting for us. Is Git tutorial what I want? No, that's not actually it. Cool. So I'm going to create a new repository as I originally said. So, first things first, if you're not familiar with it, GitHub is located at github.com. I would recommend setting yourself up with an account. If you didn't see, I pressed a button that said Create New Repository, which is on the GitHub homepage. So I'm going to call this repository demo. I'm not going to give it a description. I'm going to make it public, and I'm going to ignore this little area for now. I will press Create Repo. Okay, now GitHub is totally awesome, and it gives you help with, like connecting like local to remote. Like that's what all these instructions are about, actually. Super cool, right? So I'm just going to go ahead and do the hard work for you. I'll copy this URL that basically represents the remote repo into my clipboard, and what I'm going to type in my command line is git remote add origin, and then put in this little URL. I'm going to hope that that worked. It should. And now I'm going to push from the local master to the remote origin that I just added. So to know that this is a success, you see this nice little star, new branch, master, master. It'll explicitly say if there was some sort of error that arose. So now I'm going to refresh this page and show you that main.py and function.py show up in my remote repo now. And another handy feature on GitHub is that you can see that there are 2 commits in the commit history, and these are the commits that I showed you earlier. So right now the remote repo history and the local repo history are exactly the same. Cool. So I'm going to turn back to the slides now. And we're going to move on to collaborating with Git. So now you have an idea of how Git can help you, an individual programmer, in organizing your code into a nice history of save points. However, oftentimes, Git is used in more collaborative settings. If you ever have a software engineering internship, chances are you'll be working on the same remote Git repo with a team. If you ever attend a hackathon, the same scenario is quite likely. So now, I'd like to focus on how Git can be used to enhance collaborative coding. More terminology. It's time to throw more buzzwords at you, but I want to clear them up before we get into really discussing them and before you even see them in my slides. Ironically, clone is something that we just saw in the tutorial. Cloning a repo means taking a remote repo and making a local copy of it. This effectively links the local and remote repos. I misspoke actually, so cloning is not something that we saw. We saw adding an origin to a local repository, which means connecting a pre-existing local repository with a new remote repository. What cloning does is it assumes that there is an existing remote repository, and then it makes a local repository to complement and be attached to that remote repository. I'm sorry for misspeaking. I had a different tutorial or demo set up earlier. Branches are used to create a parallel history of the code in order to develop new features, experiment with ideas, or fix bugs without interrupting the code in the main history. I'll discuss branches in great detail in just a few slides. Fork is a GitHub-specific term. It involves creating a copy of someone else's repository at a given point in time, often an open source repository, and placing it under your GitHub username and/or storing it on your local machine with the intent of making changes to it. You fork an open source repository in order to start working on it. Pull request, or PR, is another GitHub-specific term. It means submitting your changes in a forked repository to the original repository, which is the preferred way of adding your contributions to open source projects. Note that your contributions do not automatically get added in. It's up to your collaborators to review, approve, and merge them. Cool. So these are the next 6 relevant Git commands for beginners. These commands are once again stuff that you would use on the command line. The git pull command is utilized to update a local repo with the latest changes from a remote repo. Perhaps one of your collaborators made some changes since you last coded. You should use git pull to sync up your remote and local repositories so that you can stay up to date. This won't mean anything to you yet, but git pull is a combination of git fetch and git merge, two commands that I will cover in a few slides. Remember the demo? Actually, the demo that I'm going to show you shortly should show git clone. So remember the demo in which we connected a pre-existing local repo to a new remote one? Git clone allows you to do just the opposite, as I mentioned previously. Say you have an existing remote repo on GitHub. What git clone does is it initializes a local repo containing the contents of the remote repo in your working directory, thereby establishing a connection from remote to local. Before I present the commands for branching, I think it's quite important that I discuss the underlying concepts. Remember way back when I was discussing the command git push origin master? I stated that origin was the remote repo and master was the local repo. This isn't entirely true. Master is actually a branch within the local repo. So what is a branch then? A branch is a parallel history of commits to the repository's main history, otherwise known as the master branch. Branches are used to develop features or work on bugs without interrupting the progress and integrity of the master branch and its history. In fact, you can see the flow of branching in the diagram on the bottom of this slide. The coder creates a branch to make a new feature, builds that new feature, and then merges that branch's history into the master history. Note that branches exist in both local and remote repos, and that it is imperative that the coder keeps them in sync. So here's our cute little branching cheat sheet. It has 5 major branching commands. Git checkout -b branch name makes a new local branch with that name and sets you up to start working on that branch. Git branch lists all local repo branches that exist. Git checkout branch name, without the flag, switches to the specified branch so that you can work on it. Git merge branch name merges the history of that branch name with the master branch. Git branch -d branch name deletes a branch. So that was all a mouthful. And it was great. But how do we make sure that the local and remote branches stay in sync? I bring to you this important branching public service announcement. Local branches are not seen in the remote repo until git push. So this means that branches only exist in the local repo until git push stores them in the remote repo as well. I mentioned that branches should be kept in sync between local and remote. Git push is something that allows you to do that. Remember a few slides ago when I said that git pull is a combination of git fetch and git merge? I'm finally about to explain what these commands actually do. Git fetch updates local branches by giving them information about their remote counterparts, but git fetch does not overwrite the code that you have been working on locally. Git merge combines the history of local and remote branches using the remote branch history we just gathered from git fetch. As you can see, git pull truly is a 2-step process. First step is determining all new commits that exist in remote branches using git fetch. The next step is merging the history of those local branches with their remote counterparts using git merge. Note that merge conflicts are super common and they arise often while using Git. This occurs when Git cannot automatically figure out how to best combine the differences between your remote and local branches in a logical history. Merge conflicts are beyond the scope of this video, but generally these can be sorted out by hand. So we have another wonderful demo coming your way, and I'm going to have to go back to GitHub to get it started. Exit this quickly. Cool. So we're actually going to create another remote repo. This time I'm going to call it Collab for collaborating remotely. It's going to be public once again, and I will initialize this one with a README, which you will see soon. So I'm not using a README for its actual purpose in this demo. The purpose of a README is to kind of allow the coder to explain what they're doing, how you can use their code, stuff like that. I'm just treating it as any old file in this demo. So, cool, create repository. So now, I misspoke earlier, but now I'm actually going to be using git clone. So, you see this clone or download button? It provides me with a nice little URL for this remote repo, and what I can do is bring the contents of this remote repo to a local repo, and that local repo will have been newly created. So I'm gonna go ahead and do that actually. First things first, I'm going to back out of this alone directory, clear the screen. I'm back on my desktop, as you might be able to see. Oops, sorry about that. And now I'm going to type git clone and then this remote repo URL. And now, if you look at the desktop, I have this repo or directory called collab. So I'm going to enter into it. Cool. And then the contents of collab readme.md matches what is in the remote repository. So the local and remote repositories are aligned right now. So I'm going to turn back to GitHub, and because I don't have another developer with me to show what collaboration might be like, let's say that the other developer was working on the README file and added something. So let's say they added this. So now, as you can see, this remote repo is going to be different than my local repo. So how can I resolve that exactly? What I do is I type git pull. First, I'm going to show what README looked like before I typed git pull. As you can tell, it's different locally than remotely. And now I'm going to type in git pull, and I'm going to check out the README again, and as you can see, the changes that were in the remote repo are now reflected in the local repo. So that's all fun, and now that we've looked a bit at cloning and git pull, we're going to look at branching, which will be super fun. So locally, I'm going to create a new branch called food. So I'm thinking about food right now. So, as you can see, when I type git branch, I'm on a new branch called food, which is not the same as master. On this branch, I'm going to create a new file, and I'm going to call it food.md. I'm going to edit this file to be called food, and then restaurants. And then I'll start a list of restaurants that I like Tomate and Solwich and Which. Yeah, these are all Evanston and Chicago things, so if you're in the area, shout out to you. So as you can see, I now have this new file. And what I want to do is commit this file and start creating a new history for the food branch. Creating a new history for the food branch. So I'm adding food.md. I'm committing adds food branch. Cool. And now I'm going to do a git push. Instead of origin master, I'm doing origin food. So what I'm doing is updating using the local food branch to update the remote repo such that it has a remote branch called food that has all these commits that I've added to it, such as adds food branch. And now if we turn to GitHub again, let's see if our new branch appeared. Oops. I'm going to go, okay. Aha, so now we're on collab, in the collab remote repo, and as you can see, GitHub just gave me a little notification that says, food, this is your newest branch that you've updated. We can switch to the food branch on GitHub and see that it has two files, food and readme, as opposed to master, which only has one file. So now we're going to look into merging the history of the food branch with the master branch locally, and then reflecting those changes in the remote repository. So how we can do that is we check out the master branch, so we're switching back to master, so you can see by that little star. And now I'm going to say git merge origin food. Let's see what our history of master looks like now. Aha, it has adds food branch here, which is super exciting. Cool. And now what we can do is do git push origin master. And let's see. Wow, both the remote and local master branches have food and readme.md. At the end of the day, what I can also do locally is delete the branch called food. And now if you check git branch, all we have is master. So cool, that gave you a little bit of a taste of working collaboratively, the idea that there is a constant pushing and pulling between remote and local repos in order to stay up to date and make changes to code. That branching is useful if you want to isolate a little side project or bug within a code base. So yeah, that's what it's like, a little taste of what it's like to work collaboratively with GitHub. I'm going to go back to the presentation for a few final slides. So we just learned about how Git works remotely, locally, individually, and collaboratively. We also used 12 Git commands across our demos. Now what can you, the budding coder, do with all this newfound knowledge? My answer? Keep using Git. Keep making errors. Keep correcting them. The only way to get better at Git is to keep using it and to run into so many hairy situations that someday they'll seem like a breeze to you because you've seen it all before. In order to get better at Git, I have a few tips. Take advantage of commands like git status and git log in order to track your progress. Use Stack Overflow and Google to find all the answers. Seriously, Stack Overflow, major props to you. You saved my life when I was learning Git. Work through the tutorials of others. Make personal cheat sheets, and above all, please ask for help, me or anyone else. For every person that is learning Git, I'm sure there's a multitude of people that knows about Git and version control and can help you out. Speaking of resources, here are a few that I found to be especially awesome. I'll post my slides in the Ladies Storm Hackathons GitHub repo soon, so be sure to check that out in order to access the actual links behind these nice underlined words. Cool guys, it's time to get started. No, this isn't a real Git command. This is just my special way of saying good luck to you as you start your journey with Git. Thank you so much for listening. Once again, this has been Elena Kafkis from Ladies Storm Hackathons. Go get started!